recording right now.
Would you like me to introduce you? That I can do.
Sure.
So I'm Kim May from the Fillmore Group. I worked with Frank to try to put our web series together for the next few weeks. And one of the things we wanted to do was make sure that we were sharing with the community some of the information that we've received from IBM recently about some updates and also about some direction changes. And you know, we're all getting inundated with hearing things about open source and Hadoop and how it's going to change the world as we know it. Those of us who have been in IT for as long as I have, at least, certainly know that there are lots of revolutionary things that basically end up impacting us in some way, but not necessarily in the global and holistic and humongous ways that people want us to believe when they're doing product marketing. So that being said, we have 3 webinars scheduled. Frank will be delivering all 3. For those of you that don't know Frank Fillmore is the president and founder of the Fillmore Group. He's a DB2 Gold consultant and an IBM champion for information management. He's been working with DB2 since the mainframe beginnings, in fact, before DB2, and has grown up with the product set. And with IBM's acquisition of Netezza a few years ago and the introduction of the IDAA, he's gotten very involved in IDAA opportunities and working with customers to exploit the features of the IDAA. So this new PTF has some new functionality that he's very excited to share. Take it away.
Thank you so much, Kim. And it's the first time you've called me a grown-up in a while, so I'll take that as a compliment. For anyone who wants to interact, you should be hearing me right now. I have everyone on the call on mute. Sometimes we get some background noises and people talking to their plumber and the kid crying and the dog barking. So we're going to work this one of 2 ways. I encourage interactivity. So if someone has a question, there is the ability in the GoToWebinar instrumentation to raise your hand. So I may not be able to get to it immediately, but throughout I'll be checking to see if there are any raised hands and try to address your question as it comes up. And then at the end of the webinar, if we have time, we're capped in an hour today. We have a lot of material to get through. I may open the mics up at that point, and then we'll run the risk of the ambient noise, but give you a chance to ask your questions then. So I'm going to go ahead and proceed. Kim conveniently took my first couple of slides about the Fillmore Group, which is fine. You know, we can keep rolling, but we've been an IBM business partner since 1989. Kim is also an IBM champion. It should be pointed out, someone who works in the community, blogs, tweets, and is going to be attending an IDAA event, IBM Z event in New York this week. The Fillmore Group focuses on DB2 technical support and consulting. We provide IBM authorized training, and we are a software reseller. So we try to provide a complete solution. That's a picture of me standing in front of a sign at IBM's Almaden lab. So I'm assuming, and assumptions are always dangerous things, but I'm assuming that if you're on this webinar, you know what an IDAA is. Otherwise, you wouldn't be interested in IDAA version 4.1 PTF 5. However, in the interest of completeness, I wanted to do a little bit of an introduction, just sort of a level setting for the folks on the call, to say this is what the IDAA is in case you're on the wrong call or there's some misconceptions. So IBM started out probably 6 or 7 years ago with the idea that they were going to try to marry an appliance to DB2 for ZOS to provide real-time analytics, the ability with very low latency to be able to examine data, transactional data generated on the ZOS platform in a way that would allow the best of both worlds, transaction processing and analytics, but one not impacting the other. So the first stab at it was something called the Smart Analytic Optimizer. That's not something that has been continued. I like to call that IDAA version 0.5. IBM replaced the appliance that they had built with Netezza after the Netezza acquisition. So it is the IBM DB2 Analytics Accelerator. The IDAA is a combination of DB2 for ZOS that we all know and love and a Netezza box. Data is copied over into the Netezza box. Queries can be run either by DB2 for ZOS natively or over on Netezza. determined by some ZPARMs and some special registers, as well as the DB2 optimizer and some heuristics. We're not going to take a real deep dive into the IDAA, but I just wanted to give that level set. The other important understanding that you need to have is that the design point is that all of the interactions with the IDAA is done through the DB2 for ZOS API. So all of the commands, all of the SQL, all of the utilities, all of the backup and recovery is all done consistently from the DB2 for ZOS. At this point, I have a couple of questions, so I'm going to reach out to first Al Di Giovanni and then to Alan Deep. Al, why don't you go ahead? I've unmuted your mic. Could you go ahead and pose your question?
Yeah, Frank, we just lost audio for a short time. It's back now.
What was that? I'm sorry.
The audio is lost.
Oh, okay. Yeah, I just paused for a second. We were switching some slides. Can you all see my? You should see a slide that has the Fillmore Group logo on the top and the IBM DB2 Analytics Accelerator. Is that what you guys are seeing now?
Yep, page 4.
Perfect. Okay. Alan, you had a question as well? I have Alan DEPE. I may have mispronounced your last name, but I had a raised hand a second ago. If there's nothing that you'd like to ask at this point, I'm going to keep rolling. So a brief overview of the models of the IDAA, and this is the NATISA portion, and you can see them roughly aligned. The N22 2002 model, which used to be known as the Striper, that's the model nickname, and the N3001 model, which is the Mako. They're roughly lined up. The 002 model is the quarter rack, half rack, full rack, dual rack, and so forth. And these are distinguished by the number of CPU cores, the number of FPGA cores, the field programmable gate arrays, which process the analytics so that the query gets moved to the data as it's spinning on disk, and as it streams the data off of disk, applies the where clause predicates and the decompression and the select clause projections and so forth. So I just wanted to point out a couple of things, primarily the amount of capacity in terabytes for data is pretty significant. Mostly, should handle most DB2 for ZOS environments. I have a screen up here to introduce a portion of the technology, a feature known as the incremental update. The reason I have this up here is that I wanted to give you a brief description of what incremental update is, because PTF 5 includes some improvements to incremental update. So incremental update is IBM's change data capture, whereby there are log readers, agents for up to DB2, 10 DB2 for ZOS subsystems, reading the DB2 for ZOS logs, and then applying those changes by passing them over to the NATISA box using the IBM change data capture, the legacy data mirror, and then applying those for up to 10 NATISA databases. So the changes are captured on the log, and then they are applied via the replication engine, the agent that runs over on NATISA, and updates those. The reason that you would use incremental update is if you had a business requirement that said, we can't wait for a weekly or even a daily snapshot of the data. our data changes in a manner other than a partition which we're building on a daily basis via a date. So we can't refresh the data by just moving one partition of the data over. We have transactions, inserts, updates, and deletes, which are occurring all over our data based on something like a account number or patient ID or something like that. We want to make sure that the data is near as possible to current as it can be. So up to about 1 minute latency is supported by the incremental update. So that's what the feature is. So now let's look at some of the PTFs, PTF5 enhancements. And before I do that, I want to get some sense of what you guys are all about. I have a series of polls. So the first thing I'm going to do is I'm going to launch poll number 1 to find out where you are in the IDAA journey. So the first one is your organization currently running an IDAA in production? And there are multiple choices. You should see that open on your screen right now. Give everyone a second to post their answer, and we can see, of the 20 or so people that we have on right now, where you stand in terms of IDAA adoption. So an interesting distribution. About 75 of you have, 75%, 80% have responded, and fully 50% have not implemented IDA or begun a formal IDA investigation. So this may be your first exposure. So we're gonna work at a very high level on what IDA is, and we've basically done that introduction. But now we're going to do a deeper dive down into the feature functionality and the new improvements. So we'll have some time for questions later on as the webinar proceeds. So I'm going to go ahead and close this now and continue with what the enhancements are. Also had a question before I get started again. Let me see. Al, you had your hand raised again. Did you have a question? Okay, I'm just going to assume that was an errant hand raise, or you had to scratch your nose or something. We'll go ahead. So the PTF5 enhancements at a glance, IDAA version 4.1, PTF number 5. Improved transparency is the way that it was described by IBM, but there was a level of synergy between the tables that were being replicated, so that if a single table replication failed, that is, I go to do an insert, update, or delete, I go to do an insert and I get a duplicate key found. This is something that should not happen in IDAA. It depends on how you manage it, but it could. And if it did, replication would fail for that table. What the enhancement has done is that table can be isolated and the rest of the tables being subscribed and replicated can continue. So you don't have one table taking out maybe 50 or 100 or 1,000 different tables that are being replicated. The next is in terms of enhanced capabilities, and this I think is going to be a very important one for a lot of people who are doing ETL processing, and that is what is called in-database transformation. So we're going to see a more detail on all of these later, but a brief introduction to whet your appetite. The Accelerator Only Tables are going to be enabled in version 5. So the design point for IDA when it was first introduced is that the data must exist both in DB2 for ZOS as well as in the Accelerator. That restriction was removed with a feature called High Performance Storage Saver. That's primarily used as an archiving tool, which says that we want to have our most current data, let's say the most recent 3 months, on DB2 for ZOS, and then the last 5 years or the last 7 years residing on the IDAA. So that is where some of the data resides on, for a particular table on the HPSS, on the Netezza box and the IDAA, and some of the data resides in DB2 for ZOS. The Accelerator Only table means that the table is only available on the accelerator, on the Netezza portion. So the reason that I might use this is I have some data transformations. I have some intermediate tables. So I take my transactional data, which presumably has already been loaded onto the Netezza, and then I model that in a star schema with fact tables and dimension tables. And then I run queries against that. There's no reason to move the data back and forth from the Netezza into DB2 for ZOS at this point. I can just leave the tables over there that I've created as part of this intermediate process. So the way that I like to think of this is sort of like a global temporary table, or something that I would use as a scratch pad. They're persistent, but they are transient in that they aren't backed up. They're not available. They're not. They're something that only the Netezza knows about, not something that DB2 for ZOS does. So we'll talk about this in more detail, but this is sort of the centerpiece of the PTF 5 enhancement. The other improvements are that PTF 5 now caches accelerated queries in the dynamic statement cache. Basically, this means that the preparation needs to be done once for queries that can be used over and over again. This is available via APAR for DB2 for ZOS version 10, and is in development for 11 and is not available yet. If you have, and these are obviously DB2 for ZOS. There are a series of statement level monitoring counters that are now available, so you can see at a more granular level the statements that are being accelerated, and we'll see some examples of this later on. Again, available in DB210, available via an APAR, DB211 in development right now. But the improvement is that you can see down to the statement level the execution statistics and the statement's eligibility for queries that are routed to the accelerator. And there is the addition of application period temporal tables. So temporal tables are the ability to be able to see back in time. I could do an update to a table today, and 3 weeks from now say, what was that procedure code, or what was that customer address 3 weeks ago, and be able to look at it from the standpoint of the business time when the update was made, and be able to query that. Temporal tables are now supported for loading and querying in the accelerator. And some additional support for SQL. So decode, LTrim, and RTrim, the trim and the NVL, which is similar to the NVL, the null value that's available in Oracle is used as the coalesce function in DB2 ANSI SQL. So that's the overview. That's the high points of all of the PTF 5 feature enhancements. Also, I think it should be mentioned that not only are feature enhancements being delivered, but also bug fixes. So we heard on a call today 73, 75, something like that, bug fixes that are available in PTF 5 as well. So be aware that all of that is available. I want to just check and see if there are any questions. I don't see any hands raised. So I'm going to go ahead and continue. And again, we'll have a chance for a Q&A at the end. So the isolation of tables in error. This is in incremental update. Tables are suspended from replication if an error on the table occurs either on the capture side or on the apply side. So decompression errors, data store errors, what I called out of sync errors, such as key mismatch or key not found on an update, or those types of things. Replication, the original process was that replication stopped for all tables. DB2 Analytics Accelerator replication tried to restart because the stop was not initiated by the user, so that's its fault tolerance. Okay, replication stopped, let me try to start it again. The error would occur again, and then the replication would stop. So basically, you were in a loop. Now, with the new enhancement, an individual table can be suspended, and replication continues automatically for the remaining tables of the subscription. Improved incremental update performance. The changes can now be applied in parallel for up to 4 tables at a time. Before that, changes were applied serially. The accelerator also detects unique key constraints of the DB2 automatically and propagates those as distribution keys and organizing keys for the tables that are enabled for incremental update. So it's actually trying to improve replication before the user had to do that automatically. So it's trying to apply the sense of what it is that you're doing. And I think I have a slide here. Let's talk about distribution and clustering for a second. I'm going to skip around. I apologize, but I want everyone on the call to understand what a distribution key or an organizing key are. So a distribution key allows you to, via a hashing algorithm, determine how the data is partitioned across worker nodes within the Netezza box. So basically, the distribution of the data, if you've ever worked with IBM's DB2 for Linux, Unix, Windows data partitioning feature, it's identical. I distribute my data, and the reason that I choose a distribution key is because I may have multiple tables which are joined together using the same key. So think of a purchase order header and a purchase order line item. I would want to distribute the data in the Netezza so that all of the purchase order headers with the same purchase order numbers and all the line items with the same purchase order numbers were on the same worker nodes so that the joins could be done without having to broadcast data throughout the appliance. So greatly improves performance. DB2 for ZOS detects this and during replication sets these keys automatically. The organizing key, on the other hand, promotes something called a zone map, which is maintained by Netezza. Think of it as a poor person's index, but the idea to determine at the extent level the minimum and maximum values found for any particular column that is part of the key. So, for example, if I have dates associated with a key, I could see the minimum and maximum dates for any extent. If I had a predicate that was looking for June 1st, 2015, and I saw from the zone map determined by the organizing key that an extent, which runs about 3 megabytes in the Netezza, only had dates from 2014, I could skip that extent, not have to read it, and speed access to the data. So these keys are now being identified automatically when they're part of the replication environment. So long explanation for what those are, but you can hopefully understand why that would be important and basically automate something that you needed to do manually before. Okay. Now, the setup and usage for parallel apply, it is an optional feature and the default is off. Parallel apply, the ability to update 4 tables at a time. It needs to be enabled per DB2 for ZOS subsystem using the configuration console. Possible impacts that you need to be aware of. The parallel apply threads might lead to high disk utilization on the accelerator. High disk utilization is going to conflict with queries that might be running. So it may impact query performance. So you need to determine whether improving the incremental update performance is worth potentially slowing down your query processing. The other important thing to understand is that the replication, the replicated tables, referential integrity is not guaranteed in all cases, meaning that I may have child rows with identified via foreign key before the primary key data is loaded. Now, that won't be a problem. We don't have declarative referential integrity on the Netezza box, but where it may be a problem is that you could run a query and find that you have child rows which don't have any matching parent rows, and that may be something that would violate your business policies or screw up your dashboards or your KPIs. So you need to be aware of the potential impacts for increasing the throughput and the parallelism of the incremental update process. And just taking a check here to see if anybody is asking a question. We've talked about the distribution and clustering in the accelerator, the automatic definition of the keys, an update statement on DB2 source table results in a delete insert when incremental update is enabled on the accelerated table. Performance of the delete statement can be heavily improved by setting the right distribution and organization keys. So that's why it's important to do that. The tables that are already enabled for incremental update are not affected. So these are only tables that are newly described after PTF 5 is installed. The accelerator uses the detected unique constraints such as primary key for automatic distribution and organizing key setting. And in most cases, that could be beneficial for your query execution as well. So you get more bang for the buck. The rules for the automatic key selection, the unique constraints that qualify are primary keys, unique constraints on non-nullable columns, unique constraints on nullable columns, and DB2 informal constraints, such as the unique keyword in a create table statement. Things that do not qualify on the DB2 side on nullable columns with a where not null clause. It's important to execute run stats before you enable it for our application, because you want to have the best statistics available in order to determine the best unique constraints to use for the key selection. In database transformation, the introduction of Accelerator Only Tables to store the intermediate or final results of data transformation or your reporting processes for ETL. So the benefit enables multi-step reporting on the accelerator and saves disk space and CPU cost on System Z currently used for the transformation and the reporting steps. So you move all of that stuff off. So we'll see some charts that allow you to see what this looks like. So today, I can have a non-accelerated table. The data is available in DB2 for ZOS only. I can have an accelerated table. The data is available in DB2 and in the accelerator. The optimizer and the heuristics determine whether or not a particular query is going to be accelerated. The bottom one is the archive table with an empty read-only table in DB2 for ZOS. Data is in the accelerator only. This is if I assumed that I was using the HPSS and I didn't keep any data in the DB2 for ZOS. All of my data is being archived. So for example, one of the applications that we see all the time for the high performance storage saver HPSS is the performance data, DB2 for ZOS, MQ, CICS, data that we gather, SMF records, OmegaMon data, DB2 performance monitor, all of that being written to a DB2 for ZOS subsystem. Now that can be moved in the HPSS. It never changes its static data, and it takes up a lot of space because we generate a lot of performance data. So the third one from the top is the one that we're interested in now, is the accelerator only table. This is a proxy table in DB2. The data resides in the accelerator only. So I've mentioned the HPSS before. I wanted to make sure that everybody could distinguish between the accelerator only tables and the HPSS. The HPSS provides a cost-effective means to retain data online for search and analysis, supports auditing and compliance. Here is an example where I would use an accelerator only table. So in this case, I have ETL on a different DBMS. The data is copied outside of DB2 in order to transform it. So I have an ETL process. You can see the broken bar up top. I move the table via FTP, DB2 high performance unload, Informatica, you name it. And that moves to a third-party DBMS. And then that data is rerouted back to DB2 for ZOS. And amazingly, we have some customers who do this on Netezza. They have DB2 for ZOS and they have standalone Netezza, and their ETL processes take the data off of DB2 for ZOS, move it to the Netezza, swizzle it around, and then copy it back to DB2 for ZOS. So they would be a prime candidate for being able to do this and be able to both perform the transformations as well as the analytics. So there are two different use cases here. One is where the data moves back to DB2 for ZOS. The other is where it remains on the third-party DBMS for query reporting. Using the Accelerator Only Tables, the ETL logic runs on the accelerator instead of on a different DBMS. In other words, the accelerator becomes your different DBMS. It's simpler to manage because all of the security policies that are currently in place would be used because they are managed via DB2 for ZOS and RACF. You get better performance and reduced latency because you're not moving the data off platform through a TCP/IP link to another server. And then the intermediate and the final results can be kept on the accelerator. So you can see that the ETL logic is running only on our green accelerator sidecar. I'm not taking up disk space and cycles on DB2 for ZOS in order to perform this. So that's use case number one. So I want to turn at this point to my colleague Kim, who is impressed by the statistic that we saw at an IBM presentation a couple months ago that said anywhere between 25 and 40% of IT budgets are spent on just moving data. The ETL process, the FTP process, replication, you name it, all of these are being used to move the data to another platform to perform these. And it makes sense. If I go back to my earlier slide, I may not want to perform the transformation processes that turns my transactional data into the star schema on DB2 for ZOS. Well, now I don't have to. So the second use case is the intermediate table usage for either analytics or reporting purposes. Applications create temporary tables. So this is what I mentioned. This is like a global temporary table that you would create in an application. They may also create regular tables and drop them after report closure. And an example is MicroStrategy. So I can have my accelerated tables. I could then do a format to insert with the select, create the temporary tables, create additional temporary tables built off of those temporary tables. They could be nested. All of those tables, the intermediate tables, would be created on DB2 for ZOS without the AOTs, the Accelerator Only Tables. And these tables must be loaded again for the queries to be accelerated. So what would happen is I would pull the data back into DB2 for ZOS, create the intermediate tables, and then load them back into the accelerator again. Well, I don't have to do any of that anymore. The data is in the accelerator already. I create the temporary tables and then run my queries against it. So with the Accelerator Only Tables, all steps are processed in the accelerator, both the create and the drop, and the insert, the format to insert with the select. So instead of creating the intermediate temporary or regular tables in DB2 for ZOS, I create them in the AOTs. So the prereq, the input tables must already be accelerated. They must be on the accelerator. It's not possible to use a non-accelerated DB2 table as input for the AOTs. So Accelerator Only Tables, historical and archival data need only reside on the accelerator. AOTs are created and dropped using DB2 DDL statements. So remember, design point. Everything happens in DB2 for ZOS. The accelerator must be started. The query acceleration behavior can have any value during the create and drop. So I can create a accelerated table even if the accelerator is set to none. As opposed to or eligible or enable. And then the accelerator is identified with the in-accelerator parameter on the create table statement in much the same way that you would specify in table space. And then you would just drop the table using the standard drop SQL DDL. Queries using AOTs can only run on the accelerator, so the queries need to be accelerated. The accelerator needs to be started. I can't run queries from DB2 for ZOS. And the query acceleration at the point that the queries are running must be set to enable eligible or all. AOTs can be subject to insert, update, and delete operations on other accelerated tables, so I can keep them in sync. Column type and SQL restrictions of accelerated tables apply to the AOT too, so not going to be doing any XML on the Accelerator Only Tables. Supported for dynamic and static SQL, currently supported for DB210 for ZOS only, but DB211 is in process. So this is great for online search and analysis and supports auditing and compliance. So before I go on to the next topic, I did want to take a pause here. I have another poll. I want to see if I want to ask you guys any questions, and then I will give you an opportunity to, let me see. We haven't finished that yet, so we're going to hold off on the poll. But I did want to take a pause here and see if there were any additional questions. If you would go ahead and raise your hand, I'm going to unmute you because I know that that's a lot to digest and you may have some questions about it. Okay, well, we're just going to keep on rolling then. So the next thing that we want to cover is the dynamic statement cache, or DSC support. New query preparation process. For a new arriving query, DB2 searches the DSC whether the query has been prepped before. I mean, this is standard procedure. The accelerated column value in the DSC defines what happened to the query when it was prepped before. So no, yes, or never. The query acceleration behavior, together with the accelerated column in the DSC, defines whether the query can be accelerated. Before the query is accelerated, DB2 checks whether the accelerator is active, whether all involved tables are enabled, all the things that it does today. The DSC can have multiple entries for the same query depending on the query acceleration behavior on when the statement was previously prepared. If there is no matching record, the query is treated like a new one and goes through the full preparation, and a new record is added to the DSC. So if you have a dynamic query, you're running it over and over again, there aren't any changes other than specific parameter markers, you can get a great deal of benefit because you're not going to be doing the prep, the optimization over and over again. You've accelerated this query before, you know you want to accelerate it again, so you just run. So the dynamic statement cache support is available via APARS for DB210. Will be available in 11, but not available yet. This is a feature provided by DB2 APARS only, so PTF 5 is not required. That is IDAA version 4.1 PTF 5. Statement level monitoring. The objective is to report an SQL statement's eligibility to be routed to the accelerator. So ZPARM or the special register for accelerator modeling must be enabled. And then you can report the SQL statement's execution statistics such as elapsed time, execution and wait times, CPU times, the number of rows, and bytes returned. So this simplifies planning and management of workloads on the accelerator. You can actually see what queries are performing and how well they're performing at a very granular level. The statement level monitoring support is exposed via the IFKIDS 316 and 401, and in the DSN statement cache table, again, available via DB2 APARS, available now for DB210, not for 11, and this feature is provided only by the DB2 APARS. PTF 5 is not required. So the application period temporal table support, I mentioned this briefly at the top of the discussion, but these are the time travel tables. I want to be able to do inserts, updates, deletes against a table, be able to manage it such that I can look back 3 weeks, 2 years, or whatever, and see what the current state of the data was at that time. So the example that I've used from my own experience is procedure codes for doctor's offices change over time. The same procedure code could be reused, and it's very important when someone files a claim. Some insurance companies allow people to file claims weeks or months later to see what the procedure code meant at the time of service, not at the time that the claim was filed. So it would be very easy using an application period temporal table to identify the description, the meaning, the reimbursement, etc., of the procedure code at that point in time. The temporal tables are a table that stores the changes as they occur, and you supply a business time with columns that indicate the time period when the data in that row was valid or in effect. So you can provide a begin time and end time for the business time period associated with each row. So the implementation is DB2 is create or alter a base table with the business time attribute and include a pair of timestamps or date columns stored by the application. Begin column represents the time at which the row data begins to be valid, and the end time when it is no longer valid or it is changed. And this is all managed automatically by DB2 for ZOS. The temporal tables are their own discussion. So you can see an example of the create table. I have a business begin and a business end date, and then I specify the period which is between business begin and business end. So this is what makes this a temporal table. The limitation is that timestamp 12 columns as business time are not supported by the Analytics Accelerator. So you'd have to use just the date or the timestamp. So I have run out of material at this point. I want to thank my colleague Patrick Becker of the IBM Böblingen lab, whose material I shamelessly poached and put to good effect today. So the first thing that I want to do is I want to run a couple of polls so you can be able to, let me see, polls, there we go. So I'm going to open the second poll. So based on what we've discussed are what IDAA, this is independent of PTF5, but what IDAA features interest you the most. Stuff we've talked about today, stuff you've learned about in the past. So CPU offload, the performance storage saver, the real-time analytics, query acceleration, or something else.
None of the above?
I have other. I do. As a matter of fact, you always got to have an extra bucket. Yeah.
You know everybody's coming up with new ideas.
So. Yeah, that's absolutely for the. So pretty evenly distributed. It looks like you guys, and I think this was where you could select more than one. So that's not a problem. But it looks like real-time analytics and query acceleration are the two most popular. And then the next poll that I want to run is of the 4.1 PTF5 features, what interests you the most? This is the one that I'm most curious about today. So the improvements in incremental updates, Accelerator Only Tables, improvements in the DSC handling of accelerated dynamic queries, statement level monitoring, temporal table support.
What do you think before you look? No, don't look. Don't look.
Okay.
Don't look.
Accelerator Only Tables. Those are the ones that I think that's really cool. Yeah, I could see a lot of benefit to that.
Most popular.
Yeah.
Most popular feature.
Yep. But improvements in incremental update are a close second.
Yes. But improvements in incremental update are part of a larger discussion, really.
Yeah, that's true. So the poll results are 50% said that improvements in incremental update, again, you could choose more than one, 64% Accelerator Only Tables. The statement level monitoring, about 36%, and then 21% for the temporal table support. A couple people were interested in the improvements in the DSC handling of the acceleration, so that must not be an issue for most of the folks on the call. Okay, and then I want to give you some contact information. Again, we're going to post the webcast itself on channel DB2, and we're going to put a link on our blog to that. We're also going to put the materials, contact information for me and Kim if you have any questions as follow-ons. And then our final poll is, how can we help? So what are the things that you need next to continue on your IDAA journey? So one-on-one technical discussion, cost analysis to help justify, conduct an IDAA POC or workload assessment, implementation assistance, administration training, etc.
And I would like to add, if you don't mind, one of the ways that we got started as an IBM business partner in promoting the IDAA was that we actually have delivered, or Frank has delivered, 4 different sessions of a 2-day hands-on IDAA training class that has been, the material was developed, and it's really specifically to help customers before they purchase the IDAA really understand what you can do with it. And I think one of the discussions just, with, what do you plan to use it for? That discussion started out with just accelerating analytics. That was what it was for. That's how it got its name. But we've seen organizations just do incredibly creative things with it. And it's something that now with some of these new features, you can do even more. So if people are interested, if you're from an organization that's just starting to look into the IDAA, there are a lot of people, a lot of resources on the IBM side that are, of course, willing to help. But if you really think that getting your hands on one, test driving it is something that's really going to help you understand it, please shoot either Frank or me an email and let us know where you're located, because one of the things we can do, we can deliver the class for free, but we can't pay for your travel. So if we get a group of folks in the Midwest, for instance, we'll see if we can find a central location and try to minimize T&L costs. But that's the one thing that we can't fund. But if that's something you're interested in, we've gotten tremendous feedback from the classes Frank has delivered, and we'd love to do more.
So Kim, the results of the poll are interesting. 80% of the folks, and I've actually shared it with them, are cost analysis to help justify the IDAA. It's all about the money, which makes sense to me. So at this point, I am going to open all of the speakers on your side so we can begin a discussion. We have about 10 minutes, 8 minutes left till top of the hour. So maybe you don't want to have your mic unmuted if you're talking about your grocery list or something like that, but be aware that I'm opening it up. So anyone want to be brave and go ahead and pose the first audio question?
Okay, darling. I'll talk to you later. Bye.
Okay, very good. Thank you.
Hey, Frank, it's Al. Question about the monitoring capability of the CDC replication. Has there been any modifications to that?
No, not that I'm aware of. So you're talking about latency, how I report back, how stale the data is?
Yes.
I don't believe that there have been any changes in that. Maybe that's just a function of interrogating the stored procedures, capturing the latency, and then making a decision. We were actually talking to another financial services customer today that have actually built some pretty sophisticated infrastructure of monitoring the latency through the stored procedure, reporting it to a table, and then having people query a table before they run their ETL processes. Right, they're saying, so if you need to have nearly sub-minute replication latency, and that's about the best you're going to achieve, and we're running about 15 minutes behind for some reason based on a batch process, then you can route your queries back to DB2 for ZOS or run them later.
Maybe it's not so you get it.
So cool. So thank you, Al. Any other questions?
Some guys when I say question, you hear people just like at home, just yelling at each other. Okay, I'm talking later.
Okay. Well, I think we're done then. Thank you all very much for joining our session today. I appreciate your input. And good luck with IDA. And as Kim said, if you have any questions or anything we can help you with follow-up, please let us know.
So he opened up. So we have a question from